Okay, picture this. You're standing right in the middle of a hyper-arid, completely unforgiving wasteland. I mean, the soil beneath your feet is completely toxic. The winds are violent. Literally nothing should be able to survive here. Yet towering right above you is this lush emerald green crop, and it hasn't just survived, it was engineered to literally consume the salt and conquer the sand. Today's explainer is the story of an impossible mission, one that amazingly is entirely real. We're talking about the western frontiers of Xinjiang, China. It's a wasteland so brutal, it's often referred to as the Sea of Death. And honestly, the conditions here are an agricultural nightmare. If you try to plant ordinary crops in this dirt, they don't just struggle for a bit, they die almost instantly. So how on earth did scientists transform this utterly barren, toxic desert into a lush ocean of grain in, get this, a mere 6 months? Well, spoiler alert, the answer isn't some miracle fertilizer or a clever new irrigation trick. It's actually a secret biological weapon. Meet Zhongzi 1048. Now, this is definitely not your average farm crop. It's a man-made intergeneric cereal hybrid. Think of it as a biological titan, explicitly designed by the Chinese Academy of Agricultural Sciences to pull off what nature alone couldn't do. It's engineered to eat salt, lock down shifting sands, and ultimately feed an entire nation. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. China's growing giant wheat-rye hybrids in its western deserts. Here's why. The crop, known as triticale, is easier to grow in challenging conditions and can provide food for both humans and animals. With that said, let's go straight to the intro.
The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much.
Section 1. The unforgiving saline desert, also known as the Sea of Death in Xinjiang. To really wrap our heads around this ecological miracle, we have to understand just how hostile this environment actually is. We aren't just dealing with a lack of water here, we're dealing with a literal chemical war zone. 1.4%, that is the baseline soil salinity level in these parts of Kashgar. Now, 1.4% might sound like a tiny number, right? But at that level, ordinary wheat doesn't even get the luxury of failing slowly. It completely fails to sprout. The toxicity acts like an impenetrable wall, immediately shutting down all the biological processes a seed needs for germination. And this creates a brutally harsh economic trap. Just like Quang Fei-ting, the executive director of Xinjiang Meising Da Biotechnology, points out, normally it would take 2 or 3 years of heavily artificially conditioning the soil just to see a single sprout, let alone turn a profit. But there was absolutely no time to wait around for years. They needed a radical, hyper-accelerated solution. They basically needed a way to bypass evolution itself.
Section 2. Forging a biological titan and the mastery of triticale. So how do you conquer a desert fast? You actually look back to a 19th century European concept called triticale, but you completely optimize it with modern biotechnology. The genetic blueprint here is like a masterpiece of structural engineering. Scientists basically took common wheat, which gives you massive yields, but, absolutely hates salt and cold, and they spliced it with rye. Rye is this rugged survivor that practically laughs at extreme weather and sandblasting. By perfectly merging the high-yield A and B genomes of the wheat with the indestructible R genome of the rye, they engineered a hexaploid organism. It has exactly 42 somatic chromosomes, and that precise ploidy level means the plant isn't just tough, it's fully fertile and stable. The end result? You get the massive yield of wheat entirely wrapped in the unyielding armor of rye. And the physical result of all this genetic engineering? It's huge! Zhongzi 1048 erupts from that toxic dirt and grows to a massive 1.6 meters tall. That's over 5 feet 3 inches. It literally towers over the researchers when they're walking through the fields. But that height isn't just for show, it's highly functional. It creates this massive, dense canopy that completely blocks out the sun, naturally suffocating competing weeds before they even have a chance to sprout. Now, that towering canopy directly translates into some serious economic muscle. We're talking about yields of up to 60 tons of forage per hectare every single year. In a region where the fragile natural grasslands are constantly on the verge of being overgrazed, this is an absolute silver bullet. It provides this massive alternative food source for livestock, which relieves the grazing pressure on the ecosystem and stops desertification right in its tracks. But wait, this biological titan wasn't just built for cattle. It's a legitimate superfood for humans too. Nutritional analyses show that triticale actually packs 13.5% more protein than standard wheat, corn, or rice. Plus, it's heavily loaded with essential amino acids like lysine, which we need for healthy development. When you mill it into flour for flatbreads or noodles, it proves that with the exact right application of biological science, a barren desert can absolutely provide a feast. Section 3. The desalination engine and its biological desalination mechanisms. Okay, this is where the story shifts from just impressive to genuinely mysterious. Let's look at how Zhongzi 1048 actually interacts with the Earth. According to applied ecological research models, when most plants face severe salt stress, they freak out. Their biological systems shut down just to preserve energy. But triticale, it is fundamentally different. When subjected to highly precise irrigation, what researchers call rewatering regimes, the plant actually uses the water as a weapon. Instead of retreating into a defensive shell, the sudden influx of moisture triggers a highly active physiological overdrive.
It basically pulls off a 3-step biological terraforming process. Step 1 is evaporative suppression. That big 1.6 meter canopy we talked about acts like a thermal shield, stopping the brutal desert sun from baking the ground and pulling those toxic salts up to the surface. Step 2 is hydraulic conductivity. Its massive, highly branched root system physically shatters the hard-pan soil, which allows the irrigation water to flush the existing surface salts deep underground. And step 3, this is the crazy one, active ion accumulation. The plant literally acts as a biological vacuum. It sucks the toxic sodium and chloride right out of the dirt and stores it safely in its stalks. So when farmers harvest the crop at the end of the season, they are physically carting the salt off the land forever. And what's the ultimate result here? It's a complete 180-degree ecological reversal. Before planting, the Earth is a barren 1.4% saline trap where absolutely nothing survives. But just 6 months later, the crop has slashed that salinity nearly in half, dragging it down to a highly manageable 0.76%. In a single season, this biological engine purifies the soil so effectively that farmers can step right in and immediately plant highly sensitive, lucrative cash crops. We're talking things like cotton and thriving nut orchards. Which brings us to section 4, next steps for humanity and a global blueprint. Because this triumph in Xinjiang, it's really just a proof of concept. The global strategy moving forward is incredibly aggressive and calculated. First, the goal is to turn these newly reclaimed lands into massive terrestrial carbon sinks to actively fight atmospheric CO2. Second, deploy these deep anchoring routes to lock down dust-prone regions, basically eliminating devastating sandstorms before they even start. Third, export this whole model of haloculture, which is saline farming, to desolate regions all over the world. And finally, to continue an incredible agricultural legacy. The scientists leading this project were actually mentored by Yuan Longping, the legendary father of hybrid rice. So this is literally the next generation picking up the torch and pushing the absolute boundaries of what is biologically possible. So why should the rest of the world care? Well, sit with this number for a second. 380 million hectares. That is the amount of salt-affected soil currently sitting on our planet globally. That is a truly terrifying amount of dead Earth. As global populations explode and fresh water vanishes, this fast-acting model of biological desalination isn't just a cool localized success story. It is desperately needed everywhere. We now know definitively that the Sea of Death can actually be engineered into a garden of life. Human ingenuity is wild, right? When pushed to the absolute brink, we can literally force nature to rewrite its own rules. So it makes you wonder, Could this giant hybrid be the definitive answer to the world's impending food crisis? I'd absolutely love to hear your thoughts in the comments below. And tell me, what piece of seemingly impossible engineering should we decode next? Thank you so much for joining me today. Stay curious, keep learning, and I'll see you in the next explainer.